Okay, hi everybody. This is the NASA Big Idea Challenge update. The last week update. Over the past couple of weeks since we last updated, we've been working on modifying our concept model. There's some updates that can make it run a little bit better. We're working on a much more robust and more accurate magnetic test bed, and we're hopefully going to test our concept model before this report is due. Again, we have kind of a tight crunch line. Our completed task that we did over the last couple of weeks was we did get our first iteration fully assembled and running, and we got some rough data from a magnetic test bed just to get a proof of concept and make sure we can move forward and spend a little bit more of our budget. So our original Gen 1 concept you can see in this video basically works by some rotating shafts that have eccentric hubs on them, very similar to a crankshaft of an engine. And so it should propagate just the same motion on each shaft. And yeah, that was our original concept. And we'll get into what we're going to change about it.
Our modifications that we'll use for the next generation is we bought some encoders. There will be one for each shaft, and we'll use those to prevent fouling. We're going to up our chassis support because it didn't support the weight of the components when we tried to set it on the ground. So we're going to do that by either adding some skis or wheels to it until we figure out how to solve that problem. And we're going to fix the leg angle it'll decrease the complexity and increase the stability and fix the amplitude.
Our first magnetic testbed design utilized a fish scale and some sticks, so we are trying to make a better version of it. This is what we're going to do. We're going to 3D print most of the components and have a wooden dowel. The actual samarium cobalt magnets that is the kind that we intend to use in our final design, and some metallic rods to support it in the same place. With this design, we can kind of set it at different angles and get a force displacement response characteristic at each angle and kind of get a better idea of how to build a mathematical model of our movements.
All right, so for testing concepts from here on out, we kind of have an order of operations that we're aiming for. The first one that we want it to work on is a smooth, flat, and hard surface like the floor. After that, once we can get it work there, our next goal is to make it work in a flat regolith simulated surface, similar to what you would find on the moon. And then we want it to be able to carry a load. Ideally, all these things would be able to be tested before we have to submit our proposal to NASA. The video that you're about to see is going to be us. The robot is on the table, but it is being supported by Kaiden. He's holding the robot. We're kind of letting it do its own thing. This is where you're going to see where it failed. The guides that we had for the legs had to be altered at the last minute due to some mathematical hiccups that we had. So the legs were not able to maintain the angle that they needed to be. That, coupled with the fact that they were at such a severe angle that they wasn't able to support the robot standing upright, put some weight. And you'll notice towards the front of the robot in the video, one of the legs kind of gets caught, and then it shears one of the shafts where things are just glued together with super glue. So that's what we're working on fixing in the next generation. So you can see here, it kind of starts to buck as he's holding it. And then this is right where that shaft sheared. I threw my phone down to unplug the battery before it did additional damage, as we did not have a kill switch as of yet.
Yeah, so project next steps, as we've kind of gone over for this, we're gonna set up a second generation, basically 2.0. Most of NASA's stuff works on the waterfall concept. So instead of very small changes and you have very small iterations like 1.01, 1.02, you basically go back to basics and start all over. So currently we're thinking a full acrylic chassis and shaft design to increase the rigidity of it. Acrylic we can chemically weld together, so it should be harder to shear. And as Cheyenne just said, we're going to start testing hopefully when in the Regulus simulate and hopefully with a load And then we need to write our budget for NASA and write the whole NASA document proposal. Thanks. If you have any questions, let us know.